So this video has a little bit spicier equations with rational exponents. The first one is going to involve common factoring first. So I'm going to look at each of these terms and notice that they all have x plus 1, and I'm going to take out my smallest fractional exponent. So I've got x plus 1 to the 1/2. I think that I can take that out of all of my terms. So in my first spot, the first thing that I'm doing is I'm going to take the first term in my equation and I'm factoring out, or I'm dividing out, x plus 1 to the 1/2. So those parts cancel and I'm left with just 4. The second thing that I'm going to do is I'm going to take the second term in my equation. So 5 times x plus 1 to the 3/2. I should have the minus there so I don't forget to include that. And then I've got x plus 1 to the 1/2. Now I'm dividing powers that have the same base, x plus 1. So that means that I'm going to subtract the exponent. So what I'm left with is minus 5 and x plus 1. And just to the exponent 1, 3/2 minus 1/2 is 2/2, which is just 1. So I'm going to write that in. And then my last question that I have in here is the last term. We'll see if I can fit it. I think I can fit it right here. I've got x plus 1 to the 5/2 divided by x plus 1 to the 1/2. So again, I'm dividing by powers that have the same base, so I'm going to subtract the exponent. 5/2 minus 1/2, which is 4/2, which is 2. So I've got x plus 1 squared. And now I can't quite solve that, so I'm going to expand and simplify by collecting like terms. So x plus 1 to the 1/2, my common factor stays the same. I've got an x squared. I've got minus 3x. And then let's see, I've got 4 minus 5 is minus 1 plus 1, which is 0. So I'm going to factor one more time, so it's as simple as can be. And I'm just going to take out the x from both sides, and I'm left with this. You can write the factors in whichever order you want to. They're all multiplied together, so that part doesn't matter. And now I've got 3 equations that I need to set equal to 0 and solve. So here, there's nothing that I can take the square root of that's going to give me 0, so there's no solution for that factor. My middle factor, x, is just x equals 0. That's one of my solutions. And then the last one is I've got x minus 3 is equal to 0, which means that x is equal to 3. Oh, let's go back for a minute here. We can actually solve this bracket here. Whoops. Okay, we're going to square both sides. We've got x plus 1 equals 0, which means that x equals minus 1, because that's going to give us our, let's see. We'll erase, it's not actually no solution. We've got x equals minus 1. And then we've got x equals 0, and then we've got x equals 3. So 3 solutions to that equation. Okay, let's try the next one. So just like the previous examples, we are going to clear the denominator of the rational exponent first. So I'm going to square both sides. That's going to leave me with x minus 3 cubed, which equals you know what? Let's try doing something different here. Let's try taking the cube root of both sides first. The only reason I'm doing this here is because I see that my right-hand side, I can cube root easily without a calculator. And that's going to give me some smaller numbers to work with. So let's see. Now, if I want to clear my denominator, I'm going to square both sides, and I get x minus 3 equals 9. Then I can bring the 3 over, which is going to give me x equals 12. So the difference here is I'm clearing the rational exponent just like we did before, but I have an expression as the base to my power, so the end is a little bit more complicated. All right, let's try these last couple of examples. So here I've got x minus 7 to the 4 equals 16. In order to clear that exponent, I'm going to take the fourth root of both sides, or raise each side to the exponent 1/4. So on my left side, I'm just left with x minus 7. On my right-hand side, I'm left with plus or minus 2. I'm taking an even root, so I'm always going to get two possible answers. So let's solve these two equations. I've got x minus 7 equals positive 2, and I've got x minus 7 equals negative 2. Solving for that gives me positive 9 and negative 9. Oh, positive 9, whoops, and minus 2 plus 7 is 5. Now I can see if I put those back in, just to double check, the part that I'm concerned about is that x minus 7. So if I put in 9 to x minus 7, I'm going to get 2. If I put 5 into x minus 7, I'm going to get minus 2. When I raise both of those to the 4, I'm going to end up with positive 16. So that's an example of an equation that has two solutions caused by taking an even root of both sides. All right, here I've got two exponents on either side of the equal sign. They both have the same base, so I'm going to deal with that first by raising each side to the 5th. That's going to leave me with x minus 3 squared and 4x. Now I've got x's on both sides, so I do have to expand and simplify the left-hand side because that's going to allow me to collect like terms and then factor my resulting expression. So I've got x squared minus 10x plus 9 equals 0. That factors nicely into x minus 1 and x minus 9, which means that I also have two solutions to this equation, x equals 1 or x equals 9. In example E, I have a negative exponent again. So I'm going to start off like I did in my previous video. I'm going to get rid of that negative exponent. So I've got 1 over 9x to the 2/3 equals 4. In order to get my x in the numerator, I'm going to flip the fraction. 9x to the 2/3 is equal to 1 over 4. Those three equations are equivalent. In order to clear my exponent, I'm going to cube both sides to clear that denominator. I get 9x squared equals 1 over 64. Then I'm going to need to take the square root of both sides, or raise both sides to the 1/2. And then I get 9x equals plus or minus 1 over 8. Comes from taking the even root. Then I'm going to divide both sides by 9. So I get x equals 1 over 72, or x equals minus 1 over 72. Okay, example F. So I'm going to start off by clearing my denominator, just like this. And I get x cubed equals negative 27 squared. Let's see. 27 times 27, so 729. And then when I take the cube root of that, I'm going to get x equals, let's see, 729 to the exponent 1 divided by 3. This is going to give me 9. So this, looking at it at first glance, would tell me that I have a solution, but I'm noticing that my x value is positive. And let's do a check and see what happens. So my left-hand side, I've got 9 to the 3 halves. On my right-hand side, I've got minus 27. So 9, I'm going to take the square root of 9, which is 3, and then cube it, which is 27. So I get positive 27 and negative 27 on the right-hand side. So therefore, there is no solution. It's caused by squaring both sides at the beginning, which eliminates whatever negative sign was there. Okay, G is a similar situation, but we're looking at it right away. There is no value there that I can put in for x that's going to give me a solution. So there is no solution because there's nothing I can raise to the exponent 0 that is going to give me a possible value. Okay, last example here. Now I'm subtracting 2 terms to equal 0, so that should be okay. I should be able to get a solution. So I am going to try, what do I want to try? I'm going to try common factoring here, and I'm going to try taking out x to the minus 3 over 2. So x to the minus 3 over 2, that's going to leave me with 1 here. I might have to write this out. I've got x to the 1/2, and I'm dividing by x to the minus 3 halves. Now when I'm dividing, that really means I'm subtracting exponents. So I'm taking away negative 3 halves. That's the same as adding. So I've got 4 halves, which is the same as 2. So I've got, when I factor that out, I get 1 minus x squared equals 0. I can keep going. I've got x to the minus 3 halves times 1 minus x and 1 plus x. I have a difference of squares. And now I've got 3 mini equations that I'm going to solve. So x to the minus 3 halves equals 0 is the first one. There's no solution there. And then here I've got 1 minus x equals 0. So x equals 1. And then I've got 1 plus x equals 0. So x equals negative 1. So this equation is one that has 2 solutions. Hopefully hearing the explanations helps you to solve some of the equations with rational exponents. Good luck.